All right. Hello, everybody. Welcome to our AWS Community Day. My name is Piers Barsky. I'm VP of Education and Research at A Cloud Guru and an AWS Serverless Hero. Today, I have the pleasure to co host our video day with Kim. Kim, would you like to introduce yourself?
Hi, everyone. My name is Kim Bonilla. I am developer marketing lead for Australia and New Zealand. I'm excited to be here today. Today, we have a really exciting and fun, jam packed day. We had a whole week for those of you who are new and joining us today. This whole week, we had cloud practitioners um, deliver some fantastic topics on data, Alexa and Connect, IoT, and machine learning. And today is our very last day of the entire Community Day Special Edition week. And we're excited to present three more topics focused on AWS and video.
I love it already. And look, indeed, you will hear from Lucas, who is an AWS principal solutions architect, about building a live streaming platform with Amplify. You will hear from Natasha, who is a talented developer at A Cloud Guru, about how A Cloud Guru does video transcoding and delivery of video at scale. It's super interesting.
It definitely is, P. And you also hear from Mike Chambers. Mike is one of our AWS machine learning heroes from Australia, and he is a very entertaining person to say the least, and on AI powered video editing.
Hmm.
Great. So, like all days this week, we have a single track. So, stay with us on the Twitch channel. You don't need to go anywhere else. We make all the talks public after the event, so you'll be able to access everything on demand. And if you have any technical issues, you can always revisit those links and watch them later on.
Kim, I promise I will not go anywhere for the next 2.5 hours. I'm like glued to this chair. So this is it. Um, it is, though, very important to remember that we have a code of conduct. So please be thoughtful and please be kind to one another. Please act with respect and behave. We will have moderators on Twitch to make sure that everybody adheres to our code of conduct.
That's right, Pete. It's important to mention that after all the talks today, we all kind of thank our presenters. They're giving us their time. They're part of the community. And our speakers will also answer your questions live today on Twitch. So be sure to ask your questions in the moderator tool. We have a fantastic team that are going to be engaging with all of you. We will be giving away some AWS credits as well. So don't forget.
Mm.
So stay tuned in the moderator tool and answer some really challenging little trivia.
Oh, I love credits. Do you think I can get some? No, probably not, right? Well, I hope somebody who deserves gets them. Um, Before we get into our first talk, I want to give a few shout outs to the people who made this entire week possible. Kim, like you said at the start, we've had a full week. It was jam packed. On Monday, we had the data day. Then we had Alexa and Connect on Tuesday. Wednesday was about IoT. Thursday was machine learning. And then today is our video day. So thank you to all of the AWS heroes for organizing this week. Thank you to our speakers, and thank you to you, our audience. Kim, I also want to thank you as well, because without your support, this entire week wouldn't have happened. And I want to thank our director, John, who is the magician behind the scenes, um, for making it all possible. Um, and of course, his apprentice, Derek, as well. So, yeah, he is a wonderful apprentice. Finally, I want to make one other shout out. I got a message from Patrick Dubois, who could be watching today's session. So, Patrick is a famous technologist and a member of the DevOps community. He co wrote the very famous DevOps handbook together with Gene Kim and Jess Humble, John Willis, and John Allspore. And actually, Patrick Dubois was one of the people who coined the term DevOps that we now, everybody now knows, loves, and uses. So, Patrick, if you're watching this cast, if you're watching this in recording, thank you for joining us. Excited to have you join our day. Well, look, enough of me, enough of us talking. Let's get into our first presentation. This first talk is from Lucas, who, as I said, is an AWS principal solutions architect. And in this talk, Lucas will teach us how to build our very own streaming platform for live or video on demand use cases using AWS. So, Director John, Director Derek, let's roll this video.
Hello, and welcome to this Community Day session. My name is Lucas, and I'm a Principal Solutions Architect at Amazon Web Services. And today, if you can see from the screen, we're going to be talking about video. And we're going to be talking about how the AWS platform and the AWS Amplify toolkit will help you integrate video capabilities into your application, whether it's video on demand, whether it's live streaming, or you name it. So, why are we putting so much emphasis on video lately? Well, I got a few figures up on the screen that I'd like you to go one by one. We can see that roughly 50% of the top 100 applications contain at least some form of media. We can see that 78% of people watch videos on a weekly basis. We can see these 2019 statistics, so this is not really taking into account a lot of what's been happening this year, that 82% of the global traffic will come from video in 2022. Imagine what has been going on at a worldwide level these days, and if you want to sum up video calls, educational content, schools moving into virtual settings, it might not be to anyone's surprise that we're potentially lowballing that number. And we can see finally that 68% of people prefer to learn via video, and that's a number that keeps increasing year on year, and that's quite a unique thing, something that's obviously been changing throughout the years, and it's quite interesting to see a trend up. So what is a video streaming service? So what are the steps that you have to go through in order to deliver video or media back to your users? So I split this up in a few different steps. So we'll start at the beginning. First of all, probably the hardest one of all, you have to create the content. You have to produce it and upload it. And that's one that we can help you upload it, but we can't help you create it. Just you got to come up with the idea. You have to go and shoot it, and you have to make sure that it's up to what is it that you want to create. After that, we need to encode it. And when we say we're talking about encode, it's about processing that file that we just created. As you can see, we're saying process that content into an adapted bitrate. And if you're familiar to Netflix or YouTube, you might have seen that you can change the resolution of your files or the frames that it plays up, and that's sort of the adapted bitrate. So we gotta create content that can be played back in multiple devices, multiple resolutions, multiple different types of bandwidth, so on and so forth. After that, we need to store it. The content needs to live somewhere, and from then on, you have to sort of go up and deliver it up to your users. You could technically deliver it or play it from where the content is stored, but traditionally, when you get to the production level delivery, you want to have that content as close to your user as possible. You want to minimize the latency that your clients need to go through in order to retrieve that content. And sort of this is where content delivery networks come in. And in the case of AWS, we got a service called CloudFront, which is our CDN network, and that CDN network is made up of hundreds of points of presence throughout the globe that are likely to guarantee that they will have one as close to your users as much as possible, right? And so when your users go and play and try to retrieve your content, they don't need to go to the source. There will be a point of presence, or there will be a location near them that is storing that content and potentially caching it if your content can be cached. After that, obviously, your users will be playing that content in your devices, and this will be happy days. So how can AWS help you? And what sort of these tools and services you have at your disposal? So we're going to talk about it specifically today about one angle of Amplify, but I wanted to start first by talking a little bit about what is Amplify. If you're not familiar with the toolkit, Amplify as a whole, Amplify the brand, is a development platform, and it's made up of a number of few different components. So we can see here that we got a CLI component, we got a console component, we got libraries, and we got components. Those components will be UI components that you will embed in your mobiles or web apps, libraries that will help you create your applications, the console that it will help you perform that CI/CD capabilities. It will help you host your applications. And then the CLI, which is what we'll be focusing on today, is the tool that will allow you to create, to provision, and to manage AWS services. The AWS Amplify CLI is quite opinionated, right? There is quite a convention of a configuration. We want to make it super easy for users to get started, to provision the resources, super easy for people that are not super familiar with AWS to jump in, write a few commands, answer a few questions, and just get up and running as quickly as possible. And if you can see here, the type of commands that you will be using with Amplify are fairly simple. You might be issuing an init command if you want to start a new project. You might be adding an API. You might be mocking if you want to do some local development as well. And once you're ready, you can push that up to the cloud and sort of, we'll take on the process of creating all of those resources. Amplify is made up of different categories, and you can see here, where we can help you. We can create APIs. So for example, if you want to stand up a new REST API or a new GraphQL API, the CLI will allow you to help that. You can do authentication, you can do interactions, analytics, real-time notifications, you can do storage, so on and so forth. There's likely to be a category that is sort of will help you with a particular use case. And so when we're talking about those categories, there's another way of looking at them. And the other way of looking at them is that effectively those categories are plugins of the wider Amplify ecosystem. And so once you start looking into that ecosystem, you realize there are what we can call first-party plugins and third-party plugins. So what we were discussing before, your data stores, your APIs, storage, and so on and so forth, those are, you might think of them as first-party plugins. Those are developed by the Amplify team themselves, but we're not limited to those. The plugin development is open source, and anyone can jump in and create their own plugins for their own needs. And sort of one of the things that we'll be talking about today is about this third-party open source plugin, which will help you with your video capabilities. If you want to get started with plugin development for AWS Amplify, I recommend you to jump into that URL. We have a Discord channel as well that you can come in and ask questions, and it's really useful. And I'll recommend to anyone to check that out, and to also check that out what the wider ecosystem has to offer. When we're talking about video, we were talking about this third-party plugin, which is the Amplify Video plugin. And basically what it allows you to do is to stand up 3 different types of architectures that will support video capabilities on AWS. You can use it alongside any other of your Amplify resources. If you can see in your example here, we're following the convention of Amplify of adding resources, and now we have a new category called video, and we can add that one to our existing Amplify project and just work alongside any other resources that we created. Because it's open source, because it's CloudFormation, for our infrastructure as code capabilities, the templates are super easy to customize, so you can go and change it as needed if you're not happy with some of the approaches that we've been taking. So let's quickly talk about some of the architectures that will be standing up using the plugin. So the first one is for live streaming capabilities. So we can see here when we're using the plugin, and we'll see in a demo in a little bit on how that works. When we select live streaming capabilities, behind the scenes, this is sort of the architecture at a high level that we'll be creating on the AWS platform to enable those capabilities back for you. So if we can see at AWS level, we'll be standing up a few different services from our Elemental Media Suite. We'll be standing up Media Live for live processing. This is where, if you remember, we were talking about the encoding part of the video. And then from then on, we have 2 paths. One is where we be packaging that video for delivery, and then one will be storing that video for playback capabilities. And then alongside those, we'll be creating a CDN or a distribution network on AWS, so we can push that content as close as possible back to our users. So in general, if you're new to live streaming, if you're new to media services, there's probably a better solution that we'll cover in just a little bit. This is really when you know what you're doing. This is probably for broadcast networks where they really understand and they really need to control every step of the way of their processing pipeline, the reproduction pipeline, and then really need to have the finer grade control on how to do things. Whereas if you're just getting started and you just want to live stream some content, you're probably looking for something a bit more hands-off on your end. The next reference architecture, or the next sort of services that we plug in together, is that video on demand solution. So this is not live streaming. This is more about, think about it as the Netflix-like solution, where you'll be storing a whole bunch of contents that your users can access at any time. And so, again, we'll be following the same sort of commands, and we'll be choosing a different option, in this case, a video on demand. And we can see that we'll be creating a processing pipeline. So we'll be uploading all of our content into an S3 bucket, or into an object store bucket on AWS. And then in a combination between Lambda and Media Convert, we'll be processing all of that content, and then we'll be storing it in a different bucket for reproduction and delivery. But alongside that, we're creating authentication and authorization. So obviously you want to potentially protect your content. You want to protect who can upload some of the content, who can reproduce some of your content. And this is the cognito piece that we have in there that will allow you to authenticate and authorize your users. And then we have our fourth box, which is our content management and metadata service. And this is sort of to enrich that playback experience that your users might have in the platform, where we may have a DynamoDB, our database, storing all of that metadata, and some Lambda functions, enriching our content, and we'll be delivering all of that back to the users using AWS AppSync, which is our managed GraphQL service. In some other examples, if you prefer to use REST APIs instead of GraphQL, you can do so. They're currently in beta. The support is only for GraphQL, but we'll be adding REST support in the short term as well. And the last architecture that I wanted to show you from the plugin is this interactive live service. So at a glance, at a very high level, this sort of produces the same type of experience that if we use the first one with the Elemental Media Suite. But in this case, we're making use of a relatively new service in the AWS platform, which is our interactive video service. So this interactive video service has been built off the backbone of Twitch.tv. For people that are familiar with Twitch, you know what I'm talking about. For people that are not familiar with Twitch, it's one of the largest live streaming sites. And sort of we'll be using that backbone to create this new managed service and managed offering. And we can see from an architectural perspective, this is a lot simpler. This is a lot more hands-off from a user's perspective. And if you're sort of new to this space and you should want to get started as soon as possible and as quickly as possible live streaming, you really want something that is quite opinionated, that has sensible defaults, that is for the most part a black box, that you don't have to really worry about creating endpoints and bit rates and latency and that sort of whole pipeline that we were talking about earlier before. And so the plugin will be creating a new instance of the interactive video service, or IVS, and alongside that we'll be creating a time metadata lambda function. Basically what that allows you to do is sort of enriching the live streaming experience. So you could potentially add annotations to your video. You can potentially enrich the whole playback capability by sending information back to your users at the specified time that you require. So our interactive video service, just as a recap, this is a fully managed service. You create it, and it gives you an endpoint, and it gives you an URL, an output URL that you can sort of watch your stream. That's all it is. It has, we'll see in a demo, but it has about 2 or 3 different options that you can choose from, and from then on we'll take over, we'll create everything that we need to create, and we'll just give you an endpoint, which is where you want to start streaming to. We're creating that time metadata service that allows you to sync video, like I was just talking about before, sort of to enrich the playback capabilities. And it has an ultra low latency mode that you can choose from, which is about 5 milliseconds, from creating to streaming back to your users, which is really, really low. So now we're gonna head and have a look at a little bit of a quick demo. Okay, so I'll turn off my camera so you can see my screen a bit more clearly once we jump into our demo environment. So let's go ahead and do that now. So as you can see my terminal right now, and I want to demo a few things today. I don't want to just demo our video capabilities, but I also want to demo the full end-to-end Amplify experience. So we're here in an empty project. Nothing has been created here. And what we'll do first is go ahead and create a new Amplify project. So we'll be issuing an Amplify init command, and this is sort of warming up us up to, I guess, the whole Amplify experience. So, Amplify followed this wizard-like approach for creating resources, and also, provides you with sensible defaults that you don't really need to think much. Most of the questions are yes or no questions, and these sort of free flow text questions are just for creating names for resources typically. So we'll go ahead and create some of our sensible defaults. We don't really care much about these today for this demo. And we'll go ahead and now we're really starting our CloudFormation provider. So CloudFormation is our infrastructure as code service on AWS. And Amplify picks up that I have a few AWS profiles, and it asks me whether I want to choose one of those. And this is for security and permissions to make sure that I have the right access to the account that I want to create those resources. So I'll say yes, and I'll pick my profile. And as soon as I pick my profile, the Amplify CLI just starts creating some of the resources behind the scenes that are needed for every Amplify project to work. So right now we're not creating any of the video capabilities that we've been talking about. We're not creating APIs. We're not creating anything like that. We're just creating the supporting infrastructure. So it just consists of a few IAM roles, our identity and access management roles. It creates a few buckets for object storage for our artifacts when we're creating things, and then it creates some of our CI/CD capabilities through the Amplify console. And as you can see, it takes just a couple of seconds, and now we're ready. Now we're ready to start creating resources, to start adding categories or plugins, if you will, into our project. So we'll go ahead and say Amplify add, and we'll say video. But you'll see that as we talked about video being a third-party plugin, it really looks and behaves in the same way as any of the standard out-of-the-box Amplify categories. There's really no difference to the experience when using third-party plugins as you were using a first-party plugin whatsoever. So we'll go ahead and select video, and again we're in this wizard-like experience, and we have three options, and these sort of reflect the three different architectures that we were discussing just before. And for the first one, we might create video on demand, and we'll say that we want to create a video on demand video capability. It's asking me for a friendly name. I'll choose my default friendly name. In here, I can sort of select the bitrate in which I want to provide video on demand back to my users. I'll leave it as the default to the adaptive bitrate, but I can hard code it, if you will, to HLS at 30 frames and 1080p, and the same one with accelerated transcoding. And if I know what I'm doing, I can bring on my own template as well. It's asking me whether this is a production environment. I'll say no. In reality, if it is a production environment, you will be saying yes, and that will be creating some of the distribution networks, the content distribution networks that we were discussing before. We don't really need those ones right this second. In here is also telling me whether I want to create a new API to manage my videos. We'll say yes. As we were discussing before, right now there's support for GraphQL, but REST will be supported soon as well. We're giving our API a name. We'll be selecting how do we want to authorize our API, and we'll say through Cognito. We'll leave the default settings for our Cognito user pool just as they are. I don't really want to do anything else with our pool. And then now we'll be asking a few questions around our API. So it's asking me whether I want to configure advanced settings. I don't really want to do that now. It's asking me whether I have a schema. we don't really have one right now. We'll select a sample model. It's asking me whether we want to edit our schema right now. We'll say yes, and I'll show you just in a second what that looks like. And it's asking me, whether do I want to define permissions in my schema, and I'll say that only admins can upload videos. And then it's asking me whether I want to override the schema, and I'll say yes. And it's asking, and we want to see the model that we just created. So let's show what that looks like at the moment. So this is our GraphQL schema. So we can see that we created two different types of types in GraphQL, and we can see that we're annotating it with AppSync specific annotations that allow us to create rules around permissions and roles and sort of the operations. And in this case, we can see that for a video object, we're allowing it to groups, and we are allowing it to the admin group, and then we can say that anyone in the admin group can create, update, delete, and read. And we can also see that if you're an authenticated user but you're not part of the admin group, all that you can do is just reading that video object. So let's head back into our terminal. So we're happy with what you're seeing, so we say okay, and now all of our resources have been built. Now all of the resources have been built locally, and as we can see here, by running an amplify status command again, we'll be seeing that we're in the dev environment, and there's a whole bunch of resources that we created locally, but we haven't really yet pushed them up to the cloud. So we're not going to do that in this demo because that will take a few minutes to complete. So we'll use that time and add a different video category right now. And in this case, we'll use the AWS option. And we'll see this one is quite a lot simpler than the rest. So we'll give it a name. We just select the quality of our stream. So we'll say it will be an HD stream. What sort of the latency that I want, whether I want the standard or the ultra low. We'll select ultra low latency, which is around 5 seconds. That's it. Those are the two options that we need with IBS. And from then on, AWS will look after it. So we'll run a subsequent status command to see what else we got in there. And now we can see that not only my video on demand video resources are there, but also my live stream resources are also in there. And if I wanted to push this up into the cloud, I'll just run an Amplify push. But we won't do that now, it's just take a little bit of time. So we'll jump ahead into a completed scenario. So I'll have this folder here, which I've created some of the resources already. So we'll run an Amplify status, and we'll see in this one here, our operation is no change. That means I've already pushed all that up into my account. All the resources have been created, and since I've done that, I haven't done any more local changes. And we can see that because we already created some of those, I already provided with my GraphQL endpoint to access my VOD architecture. So the last thing that we can do is to sort of say, for example, we can issue the video plugin specific commands, so we can get the information for one of our resources. So for our video on demand resources, we want to get some information, and we can see here our input storage bucket. So this is a bucket name where we're expecting our video files to drop into, and the URL that will be playing back some of that content if we choose to. So let's head back into our presentation right now. So that's all I had from a demo perspective. I hope you enjoyed the session. We'll have some time for Q&A after this as well. So thank you for tuning in, and looking forward to your questions. Bye-bye.
All right, and we are back, and we have Lucas joining us. Lucas, first of all, thank you so much for your presentation. I haven't used Amplify a lot myself, so it was great to watch your talk and see how you use it. We do have a few questions. Some is from our Twitch audience, and some are from Kim and myself. So I'll kick it off. Oh, that's a tricky one. What is the best low bandwidth video codec?
Um, I guess you probably have to think about what you want to do with your video first, whether you want to stream it in real time, whether you want to do video on demand delivery. It really comes down to it. I think H.264 is probably one of the better options out there that you can choose from. And sort of depending which solution do you use from the session that we just played, you'll get it out of the box with some of the services.
That sounds good. And do you know if encryption causes a lot of latency issues, or is it not a factor these days with super fast powered CPUs?
I mean, encryption adds latency like any other processing that you do when you're transferring data from A to B. It doesn't really add much more than what you're currently experiencing with this current stream, or when you visit any other website. It's just securing the connection between your computer and the system. So it doesn't really, it's not something that you will turn off just to improve performance. And if you're using AWS to live stream, I think we struggle to turn off encryption as well, because we like to be secure out of the box.
Yeah, just be secure. I agree. Just keep it on. I mean, come on. All right, I'll stop hogging all the questions. Kim, your turn.
Yeah, well, there's several questions I think that we all want to ask you. Let's start with if you had another month, what would you add or remove from your solution?
Wow. I think with IBS, with the live streaming service, we have that metadata service that you can do some funky things. And if you're a Twitch user and you sometimes you jump into a particular stream and they have this very interactive overlay, that's what that service is aimed to do. And if I would have another month, I would have really liked to, as a part of the demo, being able to create an overlay for this session, and people will be able to interact, and maybe something simple like rating it plus minus. I don't know. That was an idea, but just being able to have, I guess, a pre-recorded, a real-time live demo concept. I think that's what I would have done.
Wow. Wait, so Lucas, you're saying with another month, you could build your own Twitch. Is that what I'm hearing?
No. just the overlay. Just the overlay. I think between Twitch and IBS, we don't need to create a new one.
Okay, right, maybe 2 months.
Yeah. 6 weeks. 6 weeks.
Okay, Kim, you go next again.
Shall I go
Sorry,
next?
I just jumped in there.
Okay, so Lucas, how about this question? Do you have any other tips or tricks or even gotchas for those who are wanting to build a similar solution?
Yeah, I mean, when you're talking live streaming, I think I presented two solutions. One, which is really the Lego pieces solutions, where you own the entire pipeline and entire distribution, and we just, if you're using this Amplify plugin, we sort of try to glue them all together. But you really need to know what you're doing at every stage of the process. And if you're using IBS, you don't really need to worry much about it. But realistically, if you want to live stream, I guess you kind of want to figure it out why you're live streaming. If you're a gamer and you want to live stream yourself playing, or doing a tech session or whatnot, you can use an existing platform like Twitch, for example. You don't really need to stand up all of this by yourself just to do it, right? So just think about it. Like, if you think about white labeling requirements are pretty important to you, or controlling the pipeline is really important to you, or being in charge of the infrastructure, or really own the cost of running it, then you might go down the path of creating it yourself on AWS. But otherwise, if you're sort of a casual streamer, there are existing platforms like Twitch that would allow you to get up and started, and you don't have to worry about pretty much anything else.
Yeah.
I mean, honestly, like, listening to this, I'm like, Kim, should we just
Interesting.
build our own streaming platform for
I
next
know.
time, for the next community day, right?
Exactly. We'd be in good hands, that's for sure.
I like it. All right, Lucas, you are conscripted. That's it. we're going to be building our platform.
He's like, what did I get myself into?
2 months. Just remember, we need 2 months to do it. Yeah.
2 months, got it. Lucas, where would you recommend beginners start if they wanted to build something like this and they were, like, let's say, pretty new to AWS, maybe hadn't really used Amplify before? Like, what are some good steps to start off with?
Yeah, I mean, I guess the two pieces of the session today, I think, are Amplify, the Amplify ecosystem as a whole. It's a really good entry place for AWS in general. And I guess this particular video plugin is a really good complement if you want to start doing some live streaming or video on demand things. So, head over to the Amplify site, get used to it. As you've seen from the demo, it's really interactive. It's asking you, very plain English questions, yes or no questions. And just behind the scenes, that's creating a whole bunch of things that you don't really need to worry about, that the service will manage for you. And on top of that, just extend it with all these third-party plugins that are out there that just keep enriching the ecosystem. So the Amplify site is open source. The Amplify framework is open source. The CLI is open source. So it's pretty easy to get started. There are various different Discord groups as well that you can join in. And the docs are pretty good. So that would be a really good starting point for me.
Lucas, could you maybe tell us a little bit more about yourself? You live in New Zealand, you're from Argentina. How did you get into tech?
I think I was 12, 13, and I bought a Visual Basic book on a subway station because I thought that was going to help me build my own video games.
Classic.
And I think we've all been there at some point. And that's what got me hooked in. I was relatively lucky to have access to a computer, so I started writing code, and I couldn't really build a game that was on the back of the book, anywhere near close to that. But I had my own tic-tac-toe, I guess, after a couple of days, and that was, I felt like hacker man there. So really, that was sort of what got me going, and sort of sparked an interest, I guess, in technology and programming. And then I branched out a little bit into a few other things, but technology and especially programming for me has always been there and will always be there.
That's great.
That's great. Lucas, I heard a rumor that you are giving a talk at reInvent. Is that true? Can you tell us more about it?
Yeah, that's just an exclusive for community days. We can call it.
My God.
Cat's out of the bag.
Yeah. So thank you for bringing that up. Wow, that wasn't scripted at all. So reInvent is coming up in a few weeks, and as a part of the first wave of content, you have a session by me. It won't be related to video or Amplify. It's on the DevOps track. We'll be talking about how to, I guess, I don't want to spoil it too much, but it's about how to enrich your deployment pipelines with a few things on the AWS platform that maybe you wouldn't consider typically to add to your pipelines, but that there are a lot of function into it, and a lot of flexibility. So yes, tune in. I should know the exact dates for reInvent right now. I feel like I'm not representing properly, but it is around the corner, the first wave of content in December. So you have plenty of good content coming out.
And for those viewers who don't know about reInvent or are not familiar with the layout, this year is the first year that's going to be virtual. So easily accessible to anyone globally, which is exciting. And I think it shows a lot that Lucas has been chosen out of thousands and thousands of technical experts to present. So it speaks volume of all the work that he's done, and how he's leading in that area as well. Well done, Lucas.
No problem. Thank you.
Looking forward to it. Yeah.
Should be good.
So shall we kick off a couple more questions? We have a little bit more time. So Lucas, rumor has it that you just got a PS5.
Oh.
First of all, how did you get that? And second off, what's your favorite game?
These are the real hardball questions starting to come out now.
Most important questions.
This is what I came for today. Enough technology. Yes, I was a lucky day one owner of a PS5. It was actually coincidence how I got it. A mate of mine actually got the PlayStation, and some priorities in his life changed, and he decided that it was going to be a bit of a distraction right now for him. So I kindly volunteered to take it off his hands, and so
It's very
all I
generous
had
of
to
you.
do was just drive by his place yesterday and pick it up on the box. And as someone that has a PlayStation 3 and skip PlayStation 4, I have a whole bunch of games to sort of catch up on. So I'm currently playing God of War, which it's been highly recommended to me, and yeah, it's been pretty fantastic.
That's
Well, you know
great.
what? I'm excited for you.
Yeah, I'm excited for me. Yeah.
My favorite is FIFA, I have to say.
Ah, yeah.
And I usually play with Argentina as my team. So there you go.
Mm.
One of the best teams out there, or one of the best players in the world.
Everyone wants Messi on their team. Yeah.
That's right.
Yeah.
Great. Should we have a look if there's any questions in the questions box? So Derek, our producer Derek, by the way, so many of you guys might know our famous Derek Bingham, who is a developer advocate for Australia and New Zealand. He's actually producing today, and you can't see him now, but he's in the background, but we can see him. So,
Yeah.
and he's also popped into the chat box. So you guys have any questions, technical questions, or if you want to know more about, community events or user groups or events such as this led by our AWS heroes, you guys can pop those questions in there. Derek's going to be answering those for everyone.
Thank you, Derek.
Shout
Great
out to
job.
Derek. Shout out to Derek.
Mm.
Man.
Well, Lucas, I guess one last question. Is there anything else that you would like to add or mention about your solution or reinvent or anything else before we close off?
Well, first of all, thank you for organizing this. It was really easy for me to participate and I guess provide content back to the community. So, I'd love to see more of this happening in the region. I think it's great to have, I guess, local speakers. And I will encourage everyone on the session to reach out if they want to know more about this. Feel free to ping me from on the media, the channels, I guess, the socials, and my email is all so public. So go for it, ping me and ask me questions. That's what I enjoy the most.
Fantastic. Well, Lucas, thank you so much for your time and for being here and answering all of the questions. We'll be watching you presenting your talk at reInvent. Thank you again.
No
Thanks,
problem.
Lucas.
Thank you. See ya.
See
All
ya.
right, we'll be right back. And welcome back once again. So, our next talk will be by Natasha Laurie, who is a talented developer at A Cloud Guru, based out of Melbourne. I work with Natasha, and I know that she's awesome. So, will be about video transcoding. It is a major part of our platform. So, Natasha will tell you how we built and improved our video transcoding pipelines. And also, she'll talk about some of the problems and solutions we encountered along the way. Should be very interesting. So let's watch it. Thank you, producer.
Hey everyone, my name is Natasha and I'm a software developer at A Cloud Guru. Video transcoding plays a huge part in our students' experience when using the A Cloud Guru platform. Today, I'm going to share with you the tale of how we do transcoding, starting from the very beginning up until current implementation today. We'll look at problems and trade-offs that we encountered along the way and how we can improve on our current implementation. If you're looking to implement or improve on a video transcoding service, I hope you find these insights helpful. So first, I'll give you a quick overview. If you haven't heard of a cloud guru, we provide quality content for our students to upskill themselves in cloud technologies. And the company was born back in 2015 by two brothers, Sam and Ryan Cronenberg. It's since grown, and we acquired Linux Academy in 2019 and have since taught 2.2 million students and counting. The first version of the Cloud Guru was built on a completely serverless architecture in just 4 weeks, utilizing AWS. Since then, the engineering team has grown, and we've built out more serverless services to support features for our students. Our students, who come from all over the world, can then watch our content on either desktop, tablet, or the mobile app. And right now we have 340 courses with 11,050 individual lessons, as well as 26 web series videos containing 503 individual web series videos. We've recently added hands-on labs content as well, so that adds an extra 1,500 videos on top. And we continue to update our catalog. Each video can range from 2 to 20 minutes depending, so that's a lot of video content. Let's also talk about what transcoding is and why it's important. So at a very high level, video transcoding is the process of changing a video's original source format to another, usually downscaling it to a more reasonable resolution or format for the end device. The process itself involves decoding a video from its original format to a decompressed format, and then encoding the uncompressed data into the desired format. So why do we need different video formats and resolutions? We want to make viewing our content compatible across multiple devices, be it PC, tablet, or mobile. And most importantly, to make sure our users are having the best experience possible on the device that they're using. You can imagine a user viewing a HD video on their phone in an area with a poor connection will be a pretty bad experience. So the more options we have available, the more users and devices we can reach, and the better the experience for everyone. So now let's go through the journey of transcoding, one chapter at a time. Of course, a cloud guru didn't start off with such high numbers of video content in the beginning, and we also didn't have a mobile application at this point. So in the beginning, in 2015, video transcoding was a manual process. The team would upload a video to an application called Handbrake, and then Handbrake would return the transcoded video files. Needless to say, before long, a new approach was needed. So we decided to introduce Elastic Transcoder, AWS's media transcoder in the cloud. It transcodes media files from one format to various other formats that can be played across multiple devices. Elastic Transcoder also provides transcoding presets for popular output formats. So you don't need to try and guess which formats work best for specific devices. So whether it's an iPhone, Samsung, or a Kindle, it caters for those different devices. In terms of cost, you pay for the minutes that you spend transcoding and the resolution that you transcode at. If you want to have a play with this, there is a free tier. So I think you can transcode 20 minutes of standard definition video or 10 minutes of high definition video per month, free of charge. Elastic Transcoder manages all of the transcoding process for you, so you don't have to worry about the underlying infrastructure. So Elastic Transcoder is built up of 4 components. We've got jobs. So jobs do the transcoding, and they can transcode files in up to 30 different formats. And then you've got pipelines. And pipelines are the queues that manage the transcoding jobs. It can process multiple jobs at the same time and starts processing jobs in the order that they were added to the pipeline. And then you've got presets. And I mentioned these presets before, but you can pick a template with some predefined settings based on what transcoding job you want to do, or you can create your own. And finally, we've got notifications. So you can use SNS to notify you of specific events, like the status of a job. So maybe it's still processing, or it's been completed, or there's been an error. With that in mind, let's carry on with the story. So in the same year, 2015, a revamp of the transcoding process took place. The initial process was totally manual, and it was about time to automate it. Typically, a content creator on our platform will need to convert an MP4 of 1080p. And 1080p is full high definition resolution. When a user watches one of our videos on a desktop, the quality by default is set to 780p, which is standard high definition. We also provide the 1080p and a lower 480p as a playback option for our users. So let's go through the process. Our content team would go to upload an MP4 file from our editor UI, which would then upload it into our S3 input bucket. The file name has the data encoded into it, so it might look something like this on the left. So course / the course name, AWS CCP, /section / component, because you'd have multiple videos that make up different sections of the course. The upload to the input bucket would trigger a Lambda function. It will be triggered on an object created event in the input S3 bucket. Then the Lambda would write out to Firebase with a processing status that it's kicked off a new job for this file. It will then pass the S3 object key as an input to the transcoder to process the MP4. Elastic Transcoder would then place the transcoded videos in the formats that we specified into an output S3 bucket. It's important to note that the configurations that we wanted to transcode our videos to were fixed in the source code at this point. Then we had a Lambda that was triggered off of an object created event in the output S3 bucket. This would then go and update Firebase with the transcoding job status set to complete. Firebase has WebSockets, so as this process is happening, data was being resynced to the browser. When the transcoder was working in the background, the status was being updated in Firebase, and then Firebase was then pushing the status to the browser as it was happening. Finally, for any students watching on the platform, they'd be accessing this content via a signed URL, which lasts for 48 hours. And they'd be watching an MP4 of 1080p, 780p, or 480p, depending. So what are the problems with this approach? At this point, we were introducing web series, and this solution is tightly coupled to courses and to Firebase. We knew we wanted to have different types of content aside from courses, and this isn't generic. Another issue is that the data is encoded into the file name. So this implementation will pass the data around the service based on the name of the file. This is how we know the file is part of a specific video in a specific course. And this is how the Firebase hierarchy was determined. Because we're using the hierarchy of course, course name, section, component, each time we read and write to Firebase, we're traversing the structure to update that content. And again, it's tightly coupled to courses. S3 supports metadata, so what we could have done is added this data as key value pairs rather than extracting it from the file name. Another issue is that the video presets were hard-coded in the source code, so we couldn't add arbitrary data throughout the process. So if you wanted to transcode a video with different configurations each time, you couldn't do that because the preset was hard-coded. And we didn't have anything like DynamoDB to store any additional data. Literally all you had was the file name being passed in the Lambda function. So how do we move away from this? So let's look at chapter 3. We knew we wanted to have different types of content, and the previous implementation tightly coupled courses to Firebase. So we decided to decouple the types of content. So now we have different services for different types of content and a service for transcoding the content itself. So we've got the content service, which is very generic. It doesn't know if a video is course or web series material or about the series or course service itself. All it cares about is the transcoding job. So the browser calls the content service to create a piece of content, and this content service returns a content ID. This content ID is then associated to a web series or a section in a course, depending on the content. Next, let's have a look at the content service itself and break down what's happening there. The content service in this diagram is a service with GraphQL endpoints that trigger lambdas that then talk to specific AWS services. I'm representing it with a GraphQL logo here. So from the content editor UI, we'd create a new piece of content via a GraphQL endpoint, which would then go and write this new content to DynamoDB. For this API call, we're able to specify the video format or definitions that we want. So we could pass 780p, 480p, or MP3, whereas in the previous implementation, we couldn't do that because it was hard-coded. Next, the content service creates a pre-signed URL so that the content can only be uploaded by content editors to our input S3 bucket. Now we do the transcoding. So we send a request to Elastic Transcoder to start a job to start transcoding the content. Now Elastic Transcoder will get the video it's been requested to transcode from the input bucket and put the transcoded video files into an output bucket once the job is complete. As the transcoding process is happening, Elastic Transcoder is giving us a job status, which is then being updated in DynamoDB. So for example, once the transcoding job has finished, it sends that status in a payload of an SNS topic. And then the Lambda subscribed to that SNS topic would go and update DynamoDB. As this is happening, the browser is polling for updates to update the UI on the processing status. This replaces the WebSockets that could be used with Firebase, but we're using Dynamo over Firebase now, so that's the trade-off here. So once the job is done, the transcoded videos are placed in the output bucket that CloudFront fronts with signed URLs for the video content. So this makes sure the content is only accessible to members of the platform. So what are the problems that we face with this current approach? Most of the solution is in CloudFormation, but not all of it. The Elastic Transcoder is not a supported resource, so we did have to set that up manually in the console. And plus, the Elastic Transcoder service is outdated. There is a new service that I'll talk about in just a second. So having come this far and the changes that we've made, what have we achieved? Well, we've managed to centralize our videos through the content service. Every bit of video content, regardless of what it's for, so web series, course, or now hands-on labs, it all uses the same interface to be transcoded. So we've moved away from that tightly coupled solution before. So how can we improve on our current implementation? Well, we'd look to rewrite some of Chapter 2. Elastic Transcoder has become outdated. It was the first AWS service to be able to transcode media files, but there is a new kid on the block called AWS Elemental Media Convert. So Media Convert can do the same things as Elastic Transcoder and more. It supports more input and output formats, as well as HEVC and H.264 compression standards. Elastic Transcoder only supports H.264. It has other new capabilities such as video quality improvements, codecs, and other add-on features. It is available in CloudFormation, so we'd be able to have a full infrastructure as code solution, which is awesome. You can generate transcoding jobs in CloudFormation as well as presets and queues. It has a similar pricing model, so you can pay as you go and pay for what you use, and the rates are based on the duration of video output. Using Media Convert is significantly cheaper though, so it will definitely help with our transcoding bills each month. I think for standard definition per minute of video output, Media Convert costs $0.0075, while Elastic Transcoder costs 0.015. So there's definitely a few pros there for switching to Media Convert from our current implementation. So this leads us to the end of our story for now. Hope you enjoyed it. Thanks so much for listening, and feel free to connect with me on LinkedIn, and I look forward to answering any questions that you might have. Thanks.
And we are back. A big thank you to Natasha for delivering this talk. Unfortunately, Natasha couldn't join us here today, but hopefully next time we can get her on camera and ask our questions. But yes, thank you, Natasha, for doing this. So look, we'll jump back to the agenda slide for, I don't know, half a minute, and then come back with our final talk for the day. Thanks.
And welcome back, everyone. We have a very exciting last session to finalize the event. Our presenter is Mike Chambers. Mike is an AWS machine learning hero, and he's going to be presenting on automated serverless AI-powered video editing. To give you a little bit more about Mike, he's one of the first in the world to become AWS certified and has gone on to train over 250,000 students in the art of AWS, machine learning, and cloud. Over to you, Mike.
Hello, welcome to my presentation for AWS Community Days 2020. I'm really looking forward to showing you the project that I've worked on. It involves serverless, and it involves machine learning, and it involves video as well, which is why it's being shown today. A little bit about me. I'm an AWS machine learning hero, and what I do day to day is I put training courses together. I try to help people get certified in AWS, and one of the things I'm focusing on right now is helping people to pass the AWS Machine Learning Specialty Certification. So if you're interested in machine learning, and you kind of really should be because it's an awesome subject area, then we'll talk more about the course that I'm making towards the end of this session. And something that not a lot of people know about me, I actually used to work in television. So I actually used to be a technical director at a TV station. I was that person behind the cameras going, camera 1, camera 2, bring in this satellite feed from wherever. That was what I did. And when I worked in television, one of the things that I began to realize is that I don't like editing video. Now, I don't mind editing my own videos, my holiday videos, or even the videos I put together for my courses. When it's my video, I kind of enjoy that. This video, no doubt, will get somewhat edited, and I'm going to enjoy that process. But editing other people's videos, I found tedious and boring, and that's why I worked in live television, because it was just so much easier. You just press buttons and call out, and things happen. So what I wanted to do in this project, and what sort of inspired me to do this, was to create a fully automated way to be able to edit videos. So I could just get the raw footage, shove it into a process, and have an edited video come out the other side. Sound too good to be true? Maybe, but I've got an interesting example of doing that right now. So let's take a look at it. A lot of people think that essentially this is the video editing process. And I guess kind of it is. We go and record some footage. That could be on our mobile phones or with an entire TV crew with us. We then make the edit. So we sit down in an editing booth and we edit together clips, and then we shove it out somewhere so that people can watch it. And these days that tends to be quite often on the internet somewhere. But really, the video editing process is a bit more complicated than just this. It kind of looks like this, where we have lots of steps in between those that we need to fill in as well. So after we've recorded the footage, we also have to get a shot list together. So we have to know what we've recorded and which bits of it we're interested in using. And then that shot list goes through to that decision-making process. Someone has to decide which of those shots are worth using, which of those shots are going to tell the story that we want to tell. Now, if you're filming something on your mobile phone, you're kind of subconsciously doing this. But if you're in a larger organization and there's lots of people milling around, well, that's what those lots of people end up doing. So after we've made those decisions about which clips we want, we can then go and do the editing process. We can grab the clips and essentially glue them together. Then we might have a rendering process. This is actually where the edit gets created into an actual file. Sometimes this happens behind the scenes with the editing software that we're using. Then we might need to do some transcoding because the internet is a big place. There are lots of different kinds of playback platforms all over the place. And we have to transcode the video such that it's going to work with the particular destination that we have in mind. And so there might be some transcoding to do. Then finally, we've got our video. We can upload that somewhere. Everybody can watch it. So there's quite a lot of steps to the process of creating a video. And this is the set of steps that I want to take a look at in this brief session. And this is the quite ambitious architecture that I want to put together. I want to be able to record something or have the video provided. Then I want to do some cloudy automation things. And Cloud is good at doing automation things, so we should be able to do that. And I want to produce a video. That's it. Put a video in one side, get an edited video out the other. Now, the video that I've chosen to demo this architecture is this one. It's Andy Jasay's 2019 reInvent keynote speech. It's 2 hours and 40 minutes long, and hopefully AWS don't mind that I'm doing this. But I'm not going to play it in its entirety. I'm going to get the automated video editing to actually look through this video and edit it for us. So what can we use? What service can we use to watch this video for us and basically extract out the contents of the video? Well, there's one of the machine learning artificial intelligence services that we can use, and it's this one. It's Amazon Transcribe. Now, what Amazon Transcribe is going to do is it's going to use natural language processing algorithms that AWS have figured out how to make work to listen to our video, and it's going to transcribe it into a text file. You can see from this snippet here, this is what the output will look like at an API level. We'll pass the video in and we'll get back a transcript of everything that's in that video. Now, it's 2 hours and 40 minutes long, like I said, so that's going to be a lot of text all in one big block. And that's kind of useful, but it also passes back this structure. This is every single word that's in that block of text split out into its start time and its end time. Now, this becomes a lot more useful when we're coming to edit the video later on. So now we can see what word is said when. Okay, so we've got the watching of our video down. This is what we're going to use. We're going to use Amazon Transcribe. Next, we need to understand the video. And to understand the video, we're going to use Amazon Comprehend. Now, Amazon Comprehend is another one of these artificial intelligence API-driven services. We can pass in documents, we can pass in sentences, we can pass in individual words, and we'll get back from Comprehend some natural language processing intelligence, if you like, about that word. You can see here that we've passed in the word more and we're being told that it's an adjective. Now, that's a really simple use for Comprehend. Comprehend's capable of doing much more than that. In fact, it's capable of doing things like sentiment analysis. So we could pass in a sentence or a document and get back from it a score about its sentiment. Is it positive? Is it neutral? Is it negative? Or is it mixed? So we can get a score out of it. And with more time, I would like to involve more of Comprehend with this architecture. But for now, we're going to use Comprehend in a light way just to look at the type of language of a word. So is it an adjective? Is it a noun? Etc., etc. I'll show you how we use that in just a moment. So that's how we're going to understand. So we've got watch or listen and understand. Next, we have to move to decide. How are we going to decide how to edit this video together? And the best way to do that, I think, is with Lambda, because we can create a Lambda function, our own function of code, that can make a decision based around some rules that we've got. So we could say, I want to edit it with all of these words, or I want to edit these sentence structures out. And in this case, what we're going to do is I'm going to choose the most commonly used adjective that Andy and guests, because there are guests in this video too, that they use, the most commonly used adjective. I'm just going to snip all of those out and shrink it together into a concise adjective-filled video. Not altogether serious, but it could be kind of amusing. And you can see other applications for this technology as well. So we'll take the transcript out, we'll give it to Lambda to make that decision. It can then go and use comprehend to say, okay, well, I found this really popular word in the video. Is that an adjective? Yes, it is. No, it isn't. If it is, and it's the most commonly used adjective, then we're going to take that and we're going to create what we call an EDL. Now, the EDL is not an Amazon term. It's not a serverless term or anything like that. It's an edit decision list. And it's kind of something that we use in video editing. We make an edit decision list, which is the choices that we've made of which clips we want to have in our final output. So with this Lambda function, what we've done is we've taken the transcript of the video, we've decided what we want to edit out, and we've made a list of all of the in and out points for that edit that we need to do, which is the edit decision list. So we're getting quite close. We've got to the point now where we know what we want. We now have to edit the video. And this is initially, I'm going to be honest, where I kind of came a bit stuck. I looked at getting an EC2 instance and getting some open source libraries and building up an instance or even a container that could do some video editing. And that's doable. But remember, I want to have this low maintenance. I don't want to have to look after a container. I don't want to have to look after an EC2 instance image. So I found, after digging around in the documentation, that guess what? AWS Elemental Media Convert can do this. So when I looked at that service when it first came out a few years ago, I thought it was mostly about converting video formats from one thing to another, or media files from one format to another. And it does do that, but it can also edit video. Who knew? I didn't know, but I do now, and so do you. You can actually take the edit decision list that we've created in a particular format, and we can pass it into this service, and it will edit the video that it's transcribing, essentially. So we can use a Lambda function to take this text file that we've created, this edit decision list, and trigger an Elemental Media Convert conversion job to go and create this file and stick the output ultimately in an S3 bucket. And that will be job done. So we've listened to the video, we've understood the video, we've made some decisions, and we finally edited the video, done some transcription, rendered it out and put it into an output bucket. So there's a lot of moving pieces here. There's a lot of services that need to be put together. If we look at them, we're using all the favorites. So we're using S3 and Lambda, as well as Transcribe and Comprehend and Elemental Media Convert. And all of these need to be somehow coordinated together. Now, there's ways of doing this, and serverless architectures are well known and well understood. And some of the simplest ones are just an event-based chain of events. So we have an S3 bucket. If we put an object into an S3 bucket, for example, a video file, then that can trigger off an event, which can in turn trigger off a Lambda function. And so that Lambda function can say, whoa, I've got a video. I now need to pass that into the next step of the process, which in this case is going to be to do a transcribe, to do a transcription job. Now that's fine, that works, but then what comes next? Well, we could take that transcription and we could itself put it into an S3 bucket, have another trigger on that bucket, have another Lambda function. But the trouble now is we're starting to lose the context of what it is we're trying to do. We have more steps that come after this transcribe job, or after comprehend, after the elemental media convert comes next. There's all these little steps that we need to do. We somehow need to maintain state between all of these steps. I've laid enough clues in there as to what we're going to use for this. We're going to use AWS step functions. So step functions allows us to create state machines that maintain state of a running process through services just like this. It puts together Lambda functions into a tree of a definition of how we want to flow and how we want data to flow. It can tap into other services as well, but predominantly here we're going to be tapping into Lambda functions, which are going to go off and call the services on our behalf. So we're going to maintain the state of the process, which some of these things are asynchronous, they take a long time. So transcribe takes a period of time, and elemental media convert also takes a long time. So we want the opportunity to be able to manage this over a long time. And we're going to do that using step functions. So let's jump into the console and have a look at what this actually looks like. We'll take a look at a couple of the Lambda functions and we'll actually have a go with this and see if it works. Of course it works, otherwise I wouldn't be telling you about this, but let's go and see it working. So here we are inside of the AWS console, and the first place I'm going to jump to is S3, and we're going to take a look at how we're using S3 to manage this. Now in here we should find 3 buckets. There we go. So we have an input bucket, an output bucket, and we also have this bucket here, which is a clip lists bucket. This is essentially where the edit decision list gets stored. So we've got sort of 3 buckets ready to go. Now the input bucket has an event configured on it so that whenever anybody puts a video in, or an object or a video into this folder, it will trigger a Lambda function. Now let's go and have a look at the Lambda functions that we've got. And we've got quite a few actually, but the one we're going to look at in particular here is going to be this one here, the auto video trigger step. So when we place the object inside of the S3 bucket, it triggers off this Lambda function. This Lambda function is going to go and call a step function. All it does is take from the input the bucket and the key, in other words, the actual object name, if you like, inside of the bucket that got placed there. So this is the video file. It then constructs together this sort of input structure here so that we can pass it into the step functions. And then we call step functions and we pass that input object in. So essentially all this is doing is translating the fact that someone's put an object into an S3 bucket and triggering off some step functions. So let's go and have a look at step functions. Here we are. So step functions as a service has inside of it state machines. It's an awkward terminology, and if I get it wrong, then just forgive me. But inside of step functions, we have this state machine, which I've set up, and you'll recognize it if we have a look at the definition of it. You'll recognize it from the slide we looked at just a moment ago. So you can see here the flow through the step function, or the state machine. So it comes in and what it does first of all, so you remember we've placed an object into a bucket. The Lambda function has then called this. We then go and call the transcribe function. And the transcribe function is going to send the video to the transcribe service to get the transcription. Now that is an asynchronous call and it takes a while. So we enter into this wait loop here, which is a mixture of how state machines work and also a Lambda function which will every time it's called check to see if that transcription job has finished. Eventually, when it has finished, we'll pass the transcription onto clipword. And clipword is a Lambda function. If we just take a look at this now, clipword is a function which will find the most used adjective. This is what we were talking about before. So we shall actually take the transcription and it will then look through it, getting all of the unique words and counting all of the unique words. Once it's done that, it will then order the list of unique words by the most used word, which is actually probably a full stop or the word a or something like that, a. But it will take that list, once it's found that list, and start to pass it through to comprehend. So you'll see here, we're actually calling the comprehend API, and we're saying, is this an adjective? And if it's not, then we'll carry on until we hit something that is an adjective. And then as soon as we found that, we'll stop, because we don't want to classify every single word in the video. And as soon as we found that, then we found the most commonly used adjective. So coming back to our step functions, that's then going to pass it into edit list, which is going to create our edit decision list. The only thing that has to do really is take those timings for those words and convert it into seconds and frames, or minutes or actually hours, minutes, seconds, and frames rather than hundredths of seconds, because we're dealing with media files. We need to deal with frames, not hundredths of a second. And then once we've got that, we then go to the media convert Lambda function, which will take that edit decision list and take the original file name, the original object name that was passed in right back at the very beginning with the state that's been maintained inside of our state machine, and pass it into Elemental Media Convert to say, please edit this file for us. And then Elemental Media Convert will deliver the file into our output bucket. So let's go to our input bucket for 1 second. Now, rather than make you sit through me uploading something into the bucket, which happens to be in Virginia, what I'm going to do is I've got an object already in here called Keynote 2019-3. So this is the same video that we were talking about before. So I'm just going to go ahead and rename that. This is a really useful little trick if you're testing stuff like this. If I rename this file, it appears to the bucket to be a new object, and it will still trigger that flow that we've just looked at. So if I go to here, actions, and I have a look through here, we've got, where is it, rename object. So I'm just going to, increment that number. So let's go to Keynote 2019-4. I hit save changes on that. Then we should be able to go over and have a look at our state machine, step functions, and we should see that that's been invoked. That's now been successfully renamed. So we go to our step functions. Let's go back up here and have a look at executions and have a look. Yes, indeed, already we have an execution of our step function running right here. So we should now have a job that's already been passed to transcribe. This is going to take a little while to do, so I'm not going to wait for that, but it'll now step through all of the steps in this step function, and it'll light them up green as it progresses through. But it's going to take longer than we've got in this presentation. So I'm just going to go back to here, go into the output bucket, and we'll find a video which I did earlier is already sat in here. So let's go and take a look at what the output video looks like. And here it is. Let's have a listen. So there you go. So most. That's obviously the most used adjective in the 2019 keynote with Andy Jassy there. Okay, so I thought that was kind of funny. It kind of worked. So what could you actually use this for? Well, clearly, this is an amazing video. I don't know why you'd want to do anything different to that. But in reality, there are some real-world practical applications for this. Imagine if you've got recorded meetings. If you've got recorded meetings and you want to convert that Lambda function to do something slightly different, pull out the questions that were asked at the end of the meeting. We could use this for media monitoring. And how about this? We could create an video editing word processor. Say, I want all of these words, and I want to glue those together in an output video. That's something fun that we could do with this technology as well. I said before at the beginning of the video that I deal with machine learning and I help people learn machine learning predominantly. And right now I'm helping people to pass the AWS Machine Learning Specialty Certification. It's an amazing certification to get, and it's an amazing subject area to be in. Now, the course that I've put together includes actually going from no knowledge about machine learning at all through what machine learning is, the different algorithms that we use in machine learning, and the different types of machine learning and different types of algorithms, all the way through to actually building our own algorithms, building our own machine learning models, and actually getting hands-on with machine learning inside of a build environment that we build hands-on in the actual course. So it's very in-depth and it's very hands-on, and I'm having a lot of fun putting this together. It's in early access now, so it's still being made. Now is the time to jump in and make sure that the course delivers what you want to see. So go and take a look, and please do connect with me on LinkedIn as well. That's where I talk a lot about machine learning and projects like this, and we have fun there too. So if you would connect with me over there, I'd love to see it. And I'm now going to be available, with any luck, to answer questions if you have them about the presentation that I've put together for you today.
Thank you, Mike. What a fantastic presentation to finish us off for the day. You know, I think the entire session was really fun to watch personally. Mike, you also presented something similar to this at a last event in India. Could you tell us a little bit more about the community day that you presented on?
In India,
Yeah.
so the AWS community over in India is awesome, and yeah, I've got a strong ties with those guys over there. It's great. We actually had some people from the Indian community presenting yesterday, because if people are watching now and they've just tuned in now and they've seen something looks a lot like yesterday, it's not a pre-record. I'm coming back for another time. So yeah, we had some guys over from India in yesterday's presentation as well, as a session as well. So that was cool. Yeah. So we looked at this. We're on a little bit slightly longer form, I guess, of this presentation, but it's just using AWS services to do fun things. That's kind of my thing. I really like doing that, and I like sort of highlighting these services that can be used for very serious applications, but you can also tie them together to do fun things. So yeah, that's why I came up with this idea, I guess, to put together this viral video editing thing. But I'm sure it could be used for more practical purposes as well.
Yeah, no, definitely. I think you do a great job of making learning fun. Could you maybe tell us a little bit more about what you do from day to day?
Sure, yeah. Look, well, so as you saw at the end of that video there, I put courses together. So I like to teach people about cloud, and I like to teach people about machine learning as well, specifically at the moment. So yeah, I got a course that I'm working on, which is targeted mostly at the machine learning specialty certification with AWS. So certification courses are very popular. Machine learning is just such a popular subject, and it's such a cool subject. It's an enormous subject. So I try to take people from like very early beginnings. So basically, I know AWS, but I don't know machine learning yet, and sort of saying, actually, it's not as scary as it seems. If you Google machine learning, you end up sort of diving into all of these mathematical formulas, and honestly, that's kind of beyond me. So there's loads of other aspects to machine learning, which are very accessible. So like working with SageMaker and all this kind of stuff. So we do all round looking at all that kind of stuff. Yeah, look, follow me on LinkedIn if you want to hook up and chat to me more, because we have a lot of conversation over on that platform too.
Pete, what are your thoughts?
Yeah, Mike, I'm curious, watching your presentation, did you run into any technical gotchas while developing the solution, or can you kind of preempt any technical gotchas that others may face if they were to do something similar?
So we're in a very privileged situation that I'm in, which is I like to put together these solutions. And honestly, if it's not going to work, then I get to sort of shelve it and work on something else. So this obviously wasn't created for like a commercial client or something. So I have to put my hand up and say I had it easy from that point of view. But in the actual solution itself, I set myself this goal of trying to create it all on AWS services, and I really wasn't sure how to do the editing part. And I did spend a bit of time. I actually got a solution working where I had an EC2 instance that I think I probably could have put it over to a Docker container, but I think it just had it running in an EC2 instance with some open source libraries on there, which could take the video file. I think you probably copied it out of an S3 bucket. I plunked it on the EC2 instance. It could do the editing and spit it out again, and it works. But it's just hard. It's just hard work, right? And we want to go serverless as much as we can. We don't want to have to manage servers. We don't want to have to manage that code and an open source library and all the stuff that comes with that. So the real win really was when I found that Elemental Media Convert actually could also be used for editing videos. I don't think that's necessarily going to be a banner at the top of like, this is its primary function, clearly, because its name is Media Convert. It has a limitation, actually, I didn't talk about in the video. It has a limitation of 99 clips, I think it is. So if you were to use this in an environment where you need to do lots of editing, then you're going to end up needing to do something slightly more sophisticated with that, and maybe sort of split the video at a higher level, and maybe chain together some media convert. But largely it came together pretty well. Look, serverless architectures inside of AWS, it's almost what it's made for these days. So yeah, pretty good.
Absolutely. One other question that I had, if you could kind of suggest to media convert to the product team, something to make it a bit easier or more powerful in your opinion, what would it be?
Oh, wow. That's a big question. So my focus most of my time is on machine learning services. So I haven't necessarily dived into it in that amount of detail. The way that it's configured is quite verbose. There is quite a lot of stuff that goes in there. It might be interesting if there could be some kind of sort of cloud side templating of the jobs that you do. Maybe that would be something. So in the code that I run, actually the Lambda function, which goes and calls the service, the Elemental Media Convert service, all it does really is it just compiles this massive JSON structure and says, here you go, use this. So if that could be if there's something could be made easier around that, then maybe that could be something. But you could extract that out pretty easily as well without having to bother those very busy people. I'm sure they're very busy.
Yeah, no, look, I agree. Yeah, I found a very similar situation myself when I was using it. Yeah, you had to be quite verbose, and that JSON is quite lengthy, but you do feel a lot of power underneath as well.
Absolutely.
Yeah.
Now, and you can imagine as well that this call also is going to include that thing which I was calling the edit decision list, which I understand that nobody else will be calling it that outside of the TV industry, but essentially the in point and the out point for all those edit points. And so that also is getting inserted into that JSON structure. So like if I was actually to look at it end to end, it would be enormous.
Have you had a look at maybe using Media Convert with other media elemental services? We had an earlier presentation from Lucas who was talking about streaming. And I know that some people do use Media Convert and the streaming elements together to create like really powerful convert plus stream solutions.
Yeah, I am very happy for people to be able to take these services and do things like Lucas was doing. It's interesting how his presentation, I noticed that one of his early diagrams looked like a much more sophisticated version of the all over the place diagram that I had at the beginning of my presentation. So, the video edit, the video process going from ingestion or actually capture on the camera all the way to final play out. Yes, he had a much more sensible and grown up way of looking at it. So yeah, I haven't tried around with the live streaming and stuff. Maybe that's something that we could do next, sort of like to extend this project out further. Actually ingesting video now with maybe whoa, what am I trying to think of that I can ingest video streams in? Kinesis video streams. So I can ingest Kinesis video streams in live and then do some of this analysis live, sentiment analysis, and pushing it out through a no. Look,
Magic.
I was live streaming for 5 hours in straight yesterday. I just want to go and have a lie down already.
I think that sounds fair. I think that sounds very fair.
That's a marathon. You guys did so well yesterday.
Derek's given me the violins in this sort of like one-way stream of information.
Well, Mike, I won't bombard you with any more tech questions. Give over to you now.
Yeah, Mike. So why don't you tell us a little bit about what you're most excited about for reInvent? Particularly, you love machine learning.
Yeah.
What are you excited about? Tell us.
Look, yeah, I'm excited. Well, I'm excited to see how reInvent works. Full stop. So obviously it's a very different experience this year. And so we're all trying to sort of figure out how we're going to work with this. And I do encourage people actually to make sure that you put your thoughts in now about how you're going to interact with reInvent. Normally you go there. If you're lucky enough to go there, you go there and you're immersed in it all the time and you can't escape it. You don't want to escape it, but it's there. Now we're going to be sort of tapping into it, I guess. So that's something that we need to bear in mind. I've tried to think about this already, obviously from an Australian time zone point of view. Do I need to fly to Vegas and be in the right time zone and sort of camp out in my front room and pretend to be awake at the wrong time? That's probably not going to work. The thing for me about is to make sure that I maintain those connections. All those people that you meet at reInvent who you're not going to meet this time around, you need to put the effort in now. And so I've started already. I'm having one-on-one conversations with the people I meet in the corridors. I was just doing that this morning, actually. So I really do that because we need to maintain this community. In terms of AWS itself and announcements and that type of stuff, obviously keen eye on the machine learning space. I am interested to see what's going to happen at a couple of different points. So everybody should know about AWS's machine learning stack is essentially split up into 3 layers. You've got the artificial intelligence layer at the top. You've got which is sort of API-driven endpoints that you can easily integrate into your applications. It's the kind of stuff that we looked at in the presentation I just did. So comprehend and transcribe are great examples of that. And there are many more as well. Recognition, we must give a shout out to recognition. In the middle there, you've got those the machine learning services, which is predominantly SageMaker and SageMaker Studio, and a lot of stuff that actually got announced last reInvent. So that's very cool as well. And then at the bottom, you've got those fundamental services, sort of like the building blocks, like the GPU powered servers and all that kind of stuff. That's where you go when you really want to get something very specific out of the platform. This layer at the top, I'm seeing more and more innovation and product announcements in that space already, and I'm really keen to see what happens when we get to reInvent. One area in particular that I'm kind of interested in, and I was talking with Gus, the co-host from yesterday, about this, was in around preparing data prior to machine learning. So that's always the hard bit, right? I've said before, machine learning's easy, it's the data that's hard. And I give Peter Hansen's a bit of stick about his day-to-day, but in reality, it's hard. Like, that's really what it's all about, is collecting data. If you didn't have that data, you wouldn't have machine learning. And so services around the preparation of data, I think, is going to be really interesting. And lo and behold, like 24 hours ago, we get this announcement about Data Brew and integration with Glue. And this is now, I haven't got into it enough yet, but it's this service which is helping people to curate their data before they push it up into probably machine learning. Is probably the destination for that. So I'm interested to see pre-built algorithms that can help us cleanse and prepare our data for machine learning. I think that's fertile ground. There's a lot of chat in the general machine learning community about that kind of thing. And I know there's a lot of smart people behind the scenes at AWS making stuff. I'd like to see what they can do with that.
We do have some questions and comments in the chat that I think would be worth bringing up. What do you guys think? Shall we? So we have,
as long as it's
some...
not Pete Hansen's, I've noticed, has now chimed in as well.
I saw that. Peter Hansen's, we see you in the chat room. Take it easy on Mike. No, it's fantastic. I think we've got a really great audience coming from around the world. Somebody's just mentioned they're from India. We do have a question here, so maybe we'll go into that. Let's have a look here. I saw one in here more about the video streaming. So if you guys have any questions, pop them in the chat. We want to make sure that we answer everyone's questions in here. We did get a comment here about reInvent on Twitch. We can't answer that just yet, but there's going to be a lot of different streaming experiences that all our customers are going to be able to access a lot of the talks. So just be on the lookout and be sure to register. You will all get updates about reInvent if you register. So just stay on top of that. Great. So Pete,
and keep an eye out for community streams as well. No doubt.
That's
I think
right.
There's conversation about us doing something in Australia.
Yep, Mike, you make a great point. A lot of the great work that individuals like yourself, so Pete, Mike, Peter Hansen's, we have Ian, Helen earlier today, and Nathan. They're all AWS community heroes. We have data heroes, IoT heroes, machine learning heroes, serverless heroes, and these are really fantastic awards and recognitions that are given by AWS to these individuals doing some amazing work in the community that are really evangelizing technology and are really engaged with you guys, the community. So be on the lookout, and if that's something that you're also interested in, we do have open nominations throughout the year, and we're more than excited to nominate you. So you can just ping us and inquire more about that. I'm more than happy to also share some more information. But heroes get an opportunity to present at reInvent, don't they, Mike?
Absolutely, and wear capes.
And wear capes. They get some perks. Pete gets some credits here and there, right, Pete?
That's true.
So you get some perks. You get swag, travel.
Yep.
This is true.
Yeah. So it's
so
great.
I see Andre's got a question. Actually, Andre 2020. He's asking, how long does it take to process this example? The example of the video that I had in my presentation just now. So that was a 2 hours and 40-minute video, long keynote session, and you should absolutely watch the original, by the way. It took, I think, about 20 minutes to do the entire process end to end. So that's to transcode the video, to transcribe the video, and then to run those Lambda functions, which clearly run very, very quickly, and then to do the final media, elemental media convert, transcode, edit the process at the end, about 20 minutes.
Yep, fantastic. Do we have any other questions here that we want to share before we kind of talk about our wrap up of the week?
I
Let's
just
have a look.
appreciate that nobody said why would you do that.
Yeah,
Appreciate.
no, I think your talk was really interesting, even though Pete says that data engineering is way better than machine learning.
Well,
Look at it.
It's a tough one.
if it wasn't for machine learning, we make the data people look good. That's all I'm going to say.
Oh, okay. Well, I'm not going to get into that banter.
Yeah.
How about we go straight into the wrap? Let's talk a little bit about this week. Pete, why don't you lead us off?
Yeah, thank you, Kim. Yeah, it's been quite an incredible week. The 5 days that we've had, full of incredible talks. I couldn't watch all of them, but now knowing that they are available online, video on demand, that's basically my weekend. My weekend is catching up on all the individual talks that I missed. So whether you are interested in data or IoT or machine learning or Alexa and Connect or video, I think there's something for everyone. So yeah, look, at least from me, again, thank you to our speakers, thank you to all the AWS heroes, thank you to our organizers, thank you to Kim, to Derek, to John, for making this event so smooth and so just so interesting. Um, I've learned a lot. I hope everybody else who has watched learned a lot. And again, if you missed anything, please, jump on YouTube, search for the days or talks that you missed, and yeah, catch up. That's really it from me. I am looking forward to Reinvent just as much as you, Kim, and Mike.
Yep.
All the announcements, my God, bring them on. That's what I say.
Oh, we're going to have a lot of announcements, and we don't even
Cannot
know what
wait.
they are, which is
Oh
the
my
most
God.
exciting thing. We hear it the very first time as customers hear it, which is very unique in Amazon culture. And I think it's a really great testament of the speed of innovation and the importance of customer obsession. We hear it when the customers do. And Pete, you nailed it. What a fantastic week. And honestly, you all can't see Derek in the background, but Derek and I want to thank the heroes. We really are so proud and so appreciative of all the work that our AWS heroes. They are absolute legends. The ANZ team from day one, day to day with Peter Hansons and Helen Anderson. We had a jam-packed session covering databases, analytics, you name it. Day two, Alexa and Connect with Ian McKay and Kesha Williams. Day three, Nathan Glover, one of our heroes from our IoT hero, our only IoT hero from ANZ, and Derek Bingham. Day four, huge day. How can we not thank Augustininos and Mike? I call him Gus because sometimes it's a little bit of tongue twister. Gus, you're my man. Awesome. He's awesome. Fantastic team of machine learning experts. If you missed it, you want to definitely go back and revisit that content. And then today, Pete, thank you. You're just always a pleasure to work with. And for many of you who do not know, Pete is the longest tenured AWS hero in Australia and New Zealand. So hats off to Pete, who has been doing some exceptional work within the community, and we couldn't say thank you any more times than we do. We're really appreciative of all his
Thank,
work. Well done, Pete.
thank you.
All right. Well, what do you think, Mike? Shall we
Yeah,
give us
look,
your take?
can I just one thing just about the community itself? So this is the first time that I've been involved with the ANZ Community Day, which wasn't a day; it was an entire week, and I think that's part of the message. It's like the community out there is who this is for, and it's really felt like a true community event. So we went with a call for papers, for a call for talks, and I was a bit nervous that we were like leaving it a little bit late, but we had so many responses, so many people in this very active community playing a part. And obviously the Twitch chat has been active on every single day. The questions have been great. The conversations have gone on afterwards as well. So yeah, just a big shout out to the community.
Yep.
It's been awesome.
For the community, by the community. Would be nothing without the community. So everyone, thank you so much for all of your hard work. And what a great day. Everyone, thank you for joining us. And I'll let Mike and Pete sign us off.
Until next time.
All right. Thanks, everybody. Stay awesome.